And also so I don't forget, I'm gonna need us all to confirm that it is recording and I'm not on mute, right? Okay. Hopefully it's picking me up. Usually it has that little like sound bar thing, so that's a little bit concerning. But so this morning I thought, okay, I'm definitely gonna record this lecture. And I did, but it was on mute. So here we go again. I put the link on our Moodle page. Maybe I can pull that up quick here. If someone could join in and just make sure that my sound is going through, that would be awesome. There's a Zoom classroom link here. Should work. I've failed to record any videos, so there are no lecture videos yet. There will be. Only because I want to make sure, because usually it'll show me kind of my volume.
This meeting is being recorded by the host or a participant. Okay, that's
hopefully me.
This meeting is being recorded.
Hey. Sounds like we're in the money. Okay, good. Okay, I think it's under control then, but I guess we'll see. If it's a successful video, I'll post it on YouTube and there'll be a link. But like I mentioned before, it's only going to show the screen and my voice, right? So just as a heads up. Okay, so, and I know it's so boring, but I have to sit down here to write, otherwise it's very hard. I need like an up high perch. There is a box down here, but I tried to grab it this morning and it broke apart. So I'm not gonna move that. Maybe I'll try later, but. Okay, so we're gonna start chapter 1 today. Here. I need a rolly chair. I need this and I need that. We're gonna start chapter 1 today, which is really just, if you've had a chance to skim it, I don't really expect you to have had a chance because I just gave it to you yesterday, and that's crazy. We're just gonna introduce a lot of terminology, right? So a lot of kind of talking about data and just how do we talk about data, right? Because that's gonna be so important when we head down the actual analysis paths, right? Because, for example, what type of variable we have is going to dictate what analyses are appropriate, right? So first we need to be able to identify, well, what kind of variable do I have, right? And so that's where we're going to start today. So there's a lot of terminology and it gets a little bit overwhelming, right? But these are terms that we're going to use throughout the course. So they'll kind of become second nature, hopefully, pretty quick. Okay, now down I go. I'm sure I'll be up again. So apologies in advance. I always have such good intentions. Kind of mid-August, I'm like, you know what? I'm going to sit down and practice my handwriting so these poor students don't have to put up with my handwriting. And then I just don't. So good intentions. Only gets a little bit better throughout the terms. You'll get used to it though. So chapter 1 is Introduction to Data, kind of a basic name. As you can imagine, we collect data and that's why we're here, right? We're here to analyze it, but first we need to, know our way around some data. So what I'm going to do is I'm actually going to screen grab from the textbook. And I'm going to use figure 1.3. Why not? Now, one thing that I will say is that these notes that I'm writing here, I post them on Moodle after class, right? So once they're done, and just so I don't miss anything, my memory gets better, right? Memory is a muscle. So the more you work it, the better you get at memorizing. So as the term goes on, I will get better at memorizing what I said in the morning, but I didn't trust myself, so I printed them off. So they'll look like this. I know, how weird. But I can't have two screens. That's weird too. But anyways, so they'll print out and you'll have them. So don't worry, they will be there for you. Because when I do stuff like this, where I just grab a whole section of the textbook, right, that's hard to keep up with. So if you just make a note of figure 1.3 from the textbook or something like that, then that should kind of get you on your way. But I do want to talk about this and just kind of use this as an example. So we can imagine we have this data set here that we've collected, and at this point in time, I don't really care what the data is, right? We just need to be able to talk about all the different components, right? And so in general, this whole thing is called a data matrix, okay? So it's a data matrix. Oh, I guess I should give myself a little bit more space here. It's a data matrix, but I'm gonna usually call it a data set just because, I don't know, it makes more sense to me. And I can never decide if data set is one or two words. There's the internet is torn, so you can use either. Okay, so whole thing, imagine an Excel spreadsheet, right? That's your data set. That's pretty self-explanatory, but we can call it a data matrix if we're looking at it like this. Okay? So of course, we have, and I'm going to use this pointer on here, or try to, since it's recording my screen. So on the side here, right, all the rows in our Excel spreadsheet, let's imagine an Excel spreadsheet, those are what we call our observations or cases, right? And then how many of them make up our sample size, right? So I'm going to use a different color here. So these are our observations or cases. And the number of cases makes up the sample size, or the number of observations is the number of, oh, and if you ever need me to, I'll clean that up a little bit, to tell you what I wrote, just let me know, okay? And sometimes I skip words, I don't know why. Sometimes they are very important words. And so you might want to clarify. I don't notice, obviously, otherwise I'd correct it. But I think that's probably pretty normal. But so if there's ever anything you need me to clarify, just let me know. So the number of observations is the sample size, and it's going to be denoted by a lowercase n. Okay, and often if you're reading studies or kind of publications and stuff like that, then they'll always use a lowercase n, and that's to denote the sample size. So the number of observations is the sample size, which we denote by n. This morning, at first, I wrote it like this, but then it just looks like a really sad face. So then I had to ditch the quotes and just kind of go for a lowercase n, right? But just remember that the lowercase n, it's going to come up, and it's going to come up often. So that's why I want to get it out of the way. we're noticing here that there's a lot of terms for the same thing, right? Observations, cases, even sample size, right, is the number of observations in cases. We're going to find that a lot. And that's what kind of makes the beginning of this course kind of tough, is because there's so many words that mean the same thing. And that's just because statistics is used by so many different fields. And, you know, if biology uses one thing, well, then finance can't use that. So then they make up their own, or, you know, they do some sort of weird mix and match. And I know psychology does like something completely different, right? And so I'm just trying to kind of expose you to all the different terms so that you can kind of mentally lump them all together to mean the same thing, right? Often I use them interchangeably, but I try to use only one term to mean one thing, but we have to make those connections in our minds. Okay, now, if we imagine the columns in our Excel spreadsheet, right, those are going to be our variables, right? And so up here, these are our variables. Now, luckily, there's only that one word, I think. Oh, now that I think about it, data science has another term for variables, I think. I can't remember. It was one I hadn't really, like targets or something. Anyways, doesn't matter. Well, to you guys it does, but you'll learn all about it in 300. So anyways, I did teach 300 last year, but not this year. So I remember there was something. Doesn't matter. For us, we'll just call them variables. Okay, so the variables are the things that we are analyzing, right? And every observation has some observation in terms of the variable as well, right? And those things vary across observations, and hence they are variables. So the variables are what we will be analyzing, right? And so, like I said, depending on what type of variable we have, that's going to dictate the appropriate analyses. Okay, and so we just need to establish and just really think about the different types of variables. Luckily, there are only two types, right? So there's really only two ways that you can go, but we need to practice it a little bit. So in general, and I noticed the textbook has kind of a similar tree, but that's okay. There's really no other way to do it. At the top of our tree, we have these variables, okay? And I'm gonna introduce them the order that the textbook introduces them and kind of works through them. And that's first with categorical variables, then with numerical variables, even though I used to do it the other way around, and old habits die hard. But anyways, here we go. So we're gonna split these into two different types, categorical and even though I'm gonna add another term here because we could also call these qualitative, right? Before I do that, I just wanna explain what a categorical variable is in general. So it's gonna be a variable where the observations in there are categories, right? So things like letter grade, those are categories, right? Hair color, what kind of car you drive, right? Those are all categories, right? And so when we look at categories, and if you read that case study, which is at the very beginning of chapter 1, they're looking at if they had a stroke or if they didn't have a stroke, right? Those are two categories. There are only two categories, so it makes it nice and easy, right? But that's a categorical variable that we're talking about, right? Did they have a stroke or no, right? So it's a yes/no situation. Okay, so those are categorical variables. Okay, so here, It's when the observations can be grouped into distinct categories. Now, there are situations where you have many, many, many categories. Postal codes, for example, right? There's so many, but there's still categories, right? So observations can be grouped into distinct categories. Now I'm gonna add the other term here. So I'm going to try to use categorical, or for this, I only use categorical, right? But another term that we could use is qualitative, right? Meaning it has some quality that you're grouping by. But I just find that categorical triggers my mind a little bit better, or at least a little bit quicker at, okay, then I have categories, right? Whereas qualitative, then I have to think, okay, then there are qualities, and qualities can be made into groups, right? Otherwise, the chain for me is a little bit longer, but whatever you'd like. If you prefer to call it qualitative, I have that link in my mind, right? So that's fine by me. But I just don't want to be, I want to try to use as few terms as I can, but we also have to know these links. Okay. So on the other hand, if we don't have categories, then we would have these measurements, right? So then we have numerical data, and a lot of our analyses is going to be analyzing numerical data, right? Can I talk about the average of something, right? As soon as I'm talking about the average, then I have numerical data, right? And so numerical data, I'll clean that up, sorry. Numerical, which can also be called quantitative, but again, quantitative quantity is some number, and so again, the chain is a little bit too long for my likings, whereas numerical, it instantly triggers me to think, okay, then it's a measurement, which is exactly what numerical data is. So here I'll add quantitative, and numerical data is when observations are measurements. In general, they're measurements. Okay. Some common examples are things like speed, distance, time, right? All these things that we can measure. Speed, distance, time, etc. And I guess I should put some examples for the categorical data, right? My go-to is hair color, maybe car type or something like that, right? Just kind of categories. Yeah. So one thing that I want you to keep in mind when you're deciding, because of course it's going to be your job as an analyst to decide, do I have a numerical variable or do I have a categorical variable, right? So that's going to be super, super important, because if you decide to use a numerical variable as a categorical variable, you should probably explain why you're doing that, right? We do that sometimes, right? income brackets. Income is numerical, but then we create these income categories because maybe we're more interested in the counts, right? Or on the flip side, if what you're interested in is something like the average, right? Then you have to be using a numerical variable, right? So as kind of a gatekeeper, I want you to ask yourself to identify a numerical variable. I want you to ask yourself, does it make sense to talk about the average, right? And so there are some kind of tricky ones where you could argue yes or no, but that's your job as an analyst to be able to argue that yes or no. And sometimes there is no right answer, right? It's just how you wanted to analyze things. Okay, and so here, I'll use pink. So ask yourself, does it make sense to talk about the average? Right? The average speed, the average distance, the average time, right? All of those make sense, right? So this is going to be your go-to argument. I use this as a numerical variable because it makes sense to talk about the average, or that's something that I would be interested in knowing about, okay? So for categorical data, we are usually analyzing counts, right? How many counts were in each category, right? And numerical data, we're usually analyzing the average or the mean, but average for now. Okay. And so if it does make sense to talk about the average, then you're welcome to use it as a numerical variable. There are a lot of pickles, like if I asked you what year of school you're in, right? Let's say first year, second year, third year, fourth year, fifth year, victory lap. All right, did one myself. So, right, but so we probably automatically would call those categorical variables, right? Because those are categories, even though they're numbers, right? There are often numbers that are actually categories, right? We already talked about postal codes, but also zip codes, right? Zip codes are just numbers, but you don't want to talk about the average zip code. It doesn't mean anything, right? So you wouldn't want to report on that. It'll make you look silly, right? So you don't want to treat it as a numerical variable, right? Things like what year of school you're in, right? That's the one we're talking about. So then you'll have to ask yourself, okay, do I want to report what average year of school we're in, right? Or do I want to talk about how many students are in each year of school? What's more what's more telling, right, of my data? I would say, so my argument would be, I'd be more interested in knowing the count in each categories, in each category, instead of just the average of the overall school, right? And so in that case, I'm going to treat it as a categorical variable, right? Now, if it was the average year of school that students were in that you were interested in, then you're treating it as a numerical variable. So you can see how it's very much kind of a game that we're playing, right? There's no right or wrong answer. And that's what people don't like about statistics, is that, of course, there are lots of situations where there are right or wrong ways to do it. But there's a lot more gray area than we're used to with math, right? So I'll write down that example. Oh, I have to finish my tree first. Anyways. Maybe I'll write example consider the year of school students are in. I'm going to specify my population, students at OC. Let's drill down, right? Students at OC are in, right? First year, second year. Yeah, I'm inconsistent there, etc. I can't bear the inconsistency. I had it superscript for one and not the other. That's weird. Right, so here, these are numbers. We can talk about the average, right? But I would treat this as a categorical variable, right? As a categorical variable. Since I would be more interested in, and this is me personally, right? I find more value in the counts in each year, right? Year of school. How many are in first year? How many are in second year? And also because we're going to see a decrease, right? People drop out, change programs, change places, change institutions, right? And so to think about that as well, right? And that might be interesting to see. So I would treat this as a categorical variable since I would be interested in analyzing the counts in each group. In analyzing the counts in each group rather than the average year of schooling. Rather than the average year of school. Right? So it's up to you to know that that's how you're going to argue it, right? What do I want to analyze? What do I want to report? And that's going to take some practice, right? So I'm not quite done. So for us, I'm happy with this kind of basic breakdown. I just want to introduce you. There are further breakdowns. And again, it's one of those kind of what field you're in. I know, for example, I haven't taught the psychology stats, but I've tutored it way back. And they go like crazy into all the different types of categorical variables. And why would that be? Well, they're analyzing all these kind of personality surveys most of the time, right? Which is like on a scale of 1 to 10, which are now categories, right? Or very much, not so much, blah, 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 those categorical outcomes. So for them, it's really important as data scientists, not super important, right? We're going to focus more on the numerical, because that would be things like income, profits, it's all money, right? So all money questions are numerical. So you can see how that's more important. Okay, so just to kind of recap here, because I wrote under my tree, a variable is either categorical or numerical. And like I said, this is going to be our focus. We focus on these, but it's good to know the rest of them, or at least a couple more. So a categorical variable can be broken into, well, lots of different types of categorical variables, right? Categories within the categorical variables. But in general, you're going to have ordinal data, which has some natural order, right? Something like, what year of school are you in? First year, second year, third year, fourth year, right? There's some natural ordering. Whereas if a categorical variable is nominal, thank you. Then there's no natural ordering. And that would be things like, what type of car do you drive? What's your hair color, right? Those things where there's no natural ordering. And that's fine. That just makes it a nominal variable. So here, ordinal has natural ordering. Things like letter grades, right? A, B, C. There's some natural ordering. And nominal variables have no natural ordering. And I like to kind of highlight the no because that's how I remember it, right? Nominal, no natural ordering. And as an example, I don't know why I always, well, I suspect I know why I always default to hair color. I think it used to be like the go-to example in a really old textbook at one point. So now I'm like, hair color. Surely I can come up with something better. Shirt color. I think we get it though. Okay, so same thing with numerical variables. We are not going to care so much whether a numerical variable is continuous or discrete. We're going to treat them the same, but let's talk about the differences between the two. So it's either continuous, meaning it's measured on a continuous scale, right? So things like speed, if I have, you know, like a speed gun, I don't know what they're called, bless you, then I can get a speed and maybe it gives it to me with 1 decimal place, right? But I know if I got a better speed gun, I could get to 3 decimal places, 4 decimal places, right? There's a continuous scale of numbers that we could be choosing from. So even though money is only to 2 decimal places, in theory, we could go deeper, we don't, right? Whereas the other option is a discrete value. Can't see the C. Discrete numerical variable, that's where we're talking about counts. So things like age, well, saying counts kind of just is all encompassing, right? As soon as you're counting something, right? 1, 2, 3, 4, 5, then you've got this discrete variable, right? It gets, for me, a little bit murky because, of course, I think I'm 36, so, but honestly, who knows? No, I'm pretty sure, right? I'm not 36 exactly, I'm 36 point something, 0.4971. I'm sure we could figure it out, right? But that's not how we talk about ages, right? I'm 36 until I'm 37. I'm 37 until I'm 38, and we'll just stop there. That's enough, right? So it just depends on how we usually talk about data. Okay. But how we analyze these two is the same, so it doesn't matter for us. So that's why I say we're just going to focus up here, but it's really good to be aware that there could be differences, right? And so here, discrete, I'll start there. Discrete is when you have counts, right? So things like age, for example. And continuous are often they have decimals, right? They don't have to have decimals. For example, if I ask you, you know, how far did you drive today? you might give me a whole number, but you could be using decimals as well, right? So so it often has decimals or has room for decimals, let's say, right? So we could use decimals. This is the statistician in me, and it's a blessing and a curse, because I'll never commit to anything. I'll say often has decimals, right? Not all the time. As soon as there's a decimal, then it's continuous. Well, no, I'll never say that. But often has decimals. I had this one statistics prof, and she used to drive me nuts. As soon as I asked her a question, she would say, yep, except. And then she'd outline all the reasons or all the times that it wouldn't work. But then it just kind of felt like, okay, so was it a yes or was it a no? So I always felt really confused by that. I get it now, because there are a lot of scenarios where it's, yeah, except. So I catch myself saying that, and I hate myself for it, but it's how it is. Okay. Good. Any questions so far? All right. So, you can go back up here, try to zoom in on. So without the summary of the variables, so often there's a summary of the variables and what they're measuring or what they've collected. But just kind of without that, let's just go through and quickly try to figure out which of these are numerical and which of these would reasonably be categorical, right? And we're not going to go to continuous or discrete or anything like that, although we could. Loan amount, I'm gonna go with numerical, right? Looks like a number, sounds like a number, it is, right? And as soon as you have money, of course, we know that that's numerical. Same thing with the interest rate, right? That's a number, right? So numerical. The term, we can talk, so here, right? What's my chain of thought gonna be here? It looks like there's only, well, it's hard to say because we only see 4 of these observations. So it's really hard to know without seeing the rest of the data. I'm going to go with numerical, although it looks like I could treat it as categorical if I wanted to. But at this point in time, I'm going to treat it as numerical because I'd be more interested in the average term, right? I might go down that analytical path and decide, oh, it actually makes more sense to talk about how many people got a 36-month term and how many people got a 60-month term. I'm just assuming that's what it's about, right? So I can change course, right? But for now, or actually, you know what? Such a compelling argument I made. Let's make it categorical. I'm not jotting these down, so I'm not committing to anything. No, but that would be my kind of my thought process, right? Then the grade is going to be categorical because they're letters, so there's nothing I can do about that, right? The state, again, categorical because there's no way I could convert them to numbers, right? Income, so total income, again, is a dollar amount, so that's numerical, right? And home ownership, because it's words, is definitely going to be categorical, right? Often we do stuff like code these as 0, 1, 2, that kind of thing, but those would still be categories, right? A 0 would represent renting, mortgage would be represented by a 1, for example, just as a heads up. But we'll cross that bridge when we get to it. Right, and so how we've classified these variables, that's going to dictate how we should analyze them. All right, so why did we collect data in the first place? Usually we have some research question in mind that we're trying to answer, right? And so then we're introducing this idea of we have some key variable that we're interested in, right? What changes affect this key variable? And that variable is going to be called our response variable. Right? It can also be called our dependent variables. So that's another one of those situations where you have multiple terms to mean the same thing. And I think in one of my textbooks that I've read, at one point, they did a weird mix and match. Like they'd use qualitative and numeric and dependent and explanatory. Very weird. Just trying to be unique, I guess. Not helpful. All right. So what was I saying? Oh yeah, why do we collect data? We collect data to answer some research question. So we collect data to try to answer a research question. Okay. Now, the main variable of interest is going to be called our response variable. Okay. The main variable of interest is called the response, and I'm going to say / dependent variable. I'm going to focus on using response, right? But it's important that you're aware of the dependent and independent terminology as well. So much. So if I've collected data, right, we know that I haven't just collected information on the response variable. I've also collected additional information, right? Hoping that those additional variables could help explain changes in the response variable, right? And so those extra variables are called explanatory variables. Okay. Any variables, and usually it's more than one, but I'll put the S in brackets just in case it can be one, but usually if you're spending the money and collecting data, you're not just going to look at just two things, you're going to collect everything that you can, right? So so any variables collected that could help explain, that could help explain changes in the response variable are called explanatory variables. Oh, and I guess I should add another one here. Explanatory / independent variables. And I like to use explanatory because we use them to help explain changes in the response variable. And I'm all out of time and I'm not going to keep you extra on a Friday. So thank you, and I'll see you on Tuesday. And hopefully this recording worked out.